Hey guys, in this lesson we are going to figure out how to calculate solutions that we need in a couple of different ways. One by diluting a concentrated solution, and the other by adding the correct amount of solute to the amount of solution. So the first one we are going to talk about is one here, and that's by adding the proper amount of solute required to the amount of solution needed. So for instance, if we require 0.5 liters of 0.2 molarity MgCl2, remember this M here for 0.2M, that means the M means it's the molarity, not the number of moles. Common misconceptions. So we need half of a liter of this. How are we going to make that? So we need to know how many moles that solution requires, so we can link it to something that we're going to weigh. So we have 0.50 liters of that, and we can use dimensional analysis, or we can use our triangle to calculate the number of moles of MgCl2 that is. So for 0.5 liters, and we know we need 0.20 moles per liter, well, we can find out that that is equal to 0.10 moles of MgCl2. Now, in order to measure out 0.10 moles of MgCl2, well, let's just figure out. We need to convert moles to grams. So we all know that I need the molar mass to calculate that. So let's quickly calculate the molar mass of magnesium chloride. So we know that it has 1 mole of magnesium, and we look in the periodic table, the atomic mass of magnesium is 24.3, and 2 moles of chloride, and the molar mass of chlorine is 35.5 grams per mole. And we get that from the periodic table. So I can add that up, and I get, well, 1 times 24.3 is 24.3, and 2 times 35.5 is 71.0. I add that up, my molar mass is equal to 95.3 grams per mole. So now I can convert my 0.10 moles of MgCl2, and I can convert that to grams. And I know that there is moles, grams, it's 95.3 grams per 1 mole. And I can calculate that out. 1/10 of that, or 0.1 times that, is 9.53 grams of MgCl2. So how I would make the solution is I would dissolve 9.53 grams of MgCl2 in 0.50 liters of H2O. And I'd mix it up and stir it until it's evenly mixed, a homogeneous mixture. So that's the first way. That's how I would actually make this solution. Another way I can make a solution is by the second method right here, is by diluting a more concentrated solution. Now this is a lot easier because you're just mixing 2 solutions rather than weighing out an amount, then dissolving it, because sometimes dissolving solutes can take a while. So what I have here is I have my relationship. And by diluting is just another way of saying adding more solvent to decrease the solution, concentration. I'm going to abbreviate concentration CONC. Now, the way I do this, the relationship that I have is M1 V1 is equal to M2 V2. That M stands for molarity, V stands for volume. So my M1 is my molarity 1. My V1 is my volume 1. My M2 is my molarity 2. And my V2 is my volume 2. So if one requires 0.5 liters of 0.2 molar magnesium chloride by diluting 1 molar magnesium chloride. Now you might even be able to solve something like this in your head, but let's go through solving this problem as it is. So if one requires 0.5 liters, liters measure volume, so this here is my volume 1 of 0.2 molarity magnesium chloride. That's my molarity 1. By diluting 1.0 molar magnesium chloride. That's my molarity 2. So I can set up an equation because I have 3 of these quantities in this equation and down here in the molarity, and I have 1 unknown. I want to know what volume I need to dilute to. So I can set up my relationship. M1 V1 is equal to M2 V2. So 0.2 moles per liter times 0.5 liters equals 1.0 moles per liter times my V2. Now that value you consider to be an x, a variable. That's what you want to solve for algebraically. So what we ultimately have here is we can pretty easily solve for V2 in this equation by dividing both sides by 1 molarity. So let's just algebraically solve that. Divide by 1.0 moles per liter. And my unit molarity cancels out, and actually I'm left with liters. So I solve for my V2, and my V2 is equal to 0.1 liters. So how I would make this solution to 0.1 liters of 1.0 molar MgCl2, I dilute to 0.50 liters. So that's how I would actually make this solution here. Now that means I would just take 0.1 liters of my stock solution, my more concentrated solution here, my M2 solution, and I would add water until it reached 0.5 liters. Essentially, I would just be adding 400 milliliters of solution. And that should make sense. If I take the volume and I multiply that by 5, I have 1/5 of the concentration, which you see right here. 0.2 is 1/5 of 1. So it makes sense. Always check to see if your answer makes sense. And that's it. We'll be doing a bunch of these, and we'll see you guys in class.